Hello and welcome. I'm Avinash Upadhyaya, and in this video I'll be attempting yet another Pulumi challenge called Holiday Shopping. The idea of the challenge is to use Pulumi to spin up the infrastructure for running a holiday shopping list application which runs in AWS on Fargate and is exposed to the external world with an application load balancer ALB and uses MongoDB Atlas as the database. So this is the high level architecture of the application that we are going to be deploying to AWS using Pulumi. There is an ALB that fronts the entire application, which is running on Fargate ECS, which has a single task of which contains two containers, the front-end container and the back-end container, which is communicating with MongoDB Atlas as its database for persistence. So there are a few prerequisites that are necessary for completing this challenge. The first one being the Pulumi account, which is the backend for our Pulumi infrastructure state, and the Pulumi CLI. I have installed the Pulumi CLI and logged into my Pulumi account as well. We can verify that with Pulumi HomeEye. It says that I am Avinash who's logged in, and we'll also need a Docker for building the containers on our machine. We have Docker installed and running. We'll also require an AWS account and the AWS CLI. I have created an AWS user with the following permissions. Although some of these permissions might not be restrictive, all of them are full access. So I've given access to the EC2 container registry to store the container images, and IAM full access to for some of the IAM permissions required, and ECS full access to create the ECS cluster, and ELB full access to create the application load balancer, and CloudWatch full access to give the ELB or ECS access to write logs to CloudWatch, and Amazon VPC full access for some of the networking aspects, and also there's a managed policy for managing the security groups of the application load balancer. I've also configured that on my local machine with AWS configure, and I have the AWS CLI installed as well. And the final prerequisite is to have a MongoDB cloud account. I have created a MongoDB cloud account, and this is a fresh account with no databases running. We'll use Pulumi to create our databases. We'll also require a GitHub account to store our code. So the first step of the challenge is to clone the source code. The source code contains some skeleton as well as the source code for the front end and back end applications. So we've cloned the application repository. Let us get into that and open it up in Visual Studio Code. And the next step would be to initialize a Pulumi stack init-dev, which will initialize a dev stack within our current application, although the stack already exists, which is fine. And we'll also set some environment variables. We'll not require the AWS access key or secret key as environment variables because we're using the AWS CLI to communicate with AWS, although we'll need to set up the MongoDB Atlas public key and private key. So the MongoDB Atlas public key can be created by going into the access manager and organization access inside the MongoDB Cloud Console, and API keys, and we can create a new API key for Pulumi. The API key will need permissions to create a project, so we'll give it organization project creator permissions as well, and the public key is the following. We'll also need to set the private key as well, which needs to be a private value and not to be exposed to the internet, although I'll be deleting the API key once the video is out. And finally we'll need to set the AWS region. I'll be using AP South 1, which is the region closest to my. And now we can start by adding the Pulumi code for creating the infrastructure. We'll start by provisioning the or creating the container images. So once we've opened the skeleton code within Visual Studio Code. We can see that there is an app folder which contains the front end and back end source code. We'll not be touching that. We'll just be using Pulumi to use that application source code and build a container and deploy it to MongoDB. Deploy it to AWS. So we'll need to add the code for creating the images of front end and back end, which will create an ECR image with the path app backend. So in app we have a directory called backend, and we also have a directory called frontend, which we'll be using to build the images. And we've also created an ECR repository called grocery list repo. And the next part would be to create the cluster and the application load balancer. The application load balancer might run into issues if you have modified your default VPC. This is using the default VPC to create the networking. And we'll also need to create the Fargate service. Once we've created the cluster, we'll be creating the Fargate service with a task, and that task contains two containers, the front and back. That is the front end and back end containers. We'll be mapping the front end containers target group to the load balancer's default target group, so that it can be exposed to the internet. And we'll leave the backend containers port mapping to 8000 because that is not exposed through the load balancer. It is just the front end that is exposed. And we're also exporting the app URL, that is the load balancer DNS name, so that we can access the website using the load balancer. So once we've added this code, we can now run Pulumi up. Which will go ahead and install some of the dependencies that are necessary, create the virtual environment, and also give us a preview of what infrastructure is going to be provisioned before we approve it for provisioning. We can now approve the deployment based on what we see in the preview. Pulumi is going to go ahead and create the following resources. Let's select yes to deploy. Pulumi has now created the infrastructure necessary to run the application. Now let us go ahead and test our application with the output app URL in our browser. We see that the application is running. We see Pulumi plus grocery list. But now if you try to add a list to things to the list, it will not persist. That is because there is no persistence enabled. There is no database connected. We've just deployed the application, the front end and back end containers onto ECS Fargate and exposed it with a load balancer. We're yet to deploy the MongoDB database. Now let's create the MongoDB database using Pulumi. We'll copy the code snippet from the challenge website and add it to the main.py file. We'll add it before the Fargate service is created, so that the Fargate service can consume the database. Let's walk through some of the code that we've added. There is a configuration defined for the database username and password, and also the Atlas organization ID. We are then creating a MongoDB project called Mongo project within the organization that we're reading through the configuration, and we're defining certain ACLs so that MongoDB can access the ECS service can access MongoDB. Although this is opening up the MongoDB to all IP access, we can restrict that based on the security group of or based on the VPC of the ECS Fargate service. And we're then finally creating a MongoDB cluster with the name Mongo cluster within the project that we created earlier. And in the US West 2 region, there are other configurations such as the size and the provider configurations. And we're also creating a MongoDB user, database user, with the user name that we had provided earlier, so that the application can access the MongoDB database with the username and password that we had passed in as configuration. And now the final step would be to actually provide the Fargate service the details about the MongoDB database. So we'll be adding an environment variable to the backend container, which will point to the MongoDB service running within Atlas. The environment variable is called database URL and is using the output from the MongoDB database that we created just above. So the code is now created. We'll just need to set some of the configuration that we defined within code. The first one is the organization ID of MongoDB, which we can find when we go to settings, and here is the organization ID. And we'll also need to set the database user and database password. It is an arbitrary name that we can provide to the user. Let's provide it as Mongo user. And we'll also need to set up the database password as a secret, which will be also an arbitrary value, Mongo password, and we'll need to make sure we pass the secret flag so that the password is not visible in plain text within the Pulumi configuration file, which is pulumi.dev.yaml. Here we see that the DB password is encrypted. This is encrypted for our user account, so we can go ahead and push this file to a Git repository as well. No one will be able to decrypt it, but the other values are in plain text because those are not really secrets and can be accessed by anyone. Finally, let us now run Pulumi up once again so that we can create the database and make sure the Fargate service communicates to the database for persistence. As usual, MongoDB or Pulumi provided us with a preview of what resources are going to be created. The created resources are with respect to the MongoDB Atlas database, and it will also update the Fargate definition to add the environment variable. Pulumi has now updated our Fargate service and also deployed the MongoDB database. Let us now verify if our grocery shopping list is working as expected. That is, it is able to persist data. Let's start with adding an item to the list. We see that it is being added to the list. Yes. So our application is working as expected, and we deployed the complete infrastructure using Pulumi. So that was it for the challenge. I hope you learned something, and thanks to Pulumi for running the challenge. Thank you, and see you in another video.